This weekend's winter storm has had quite a few twists and turns. I'm sure it still has some tricks left up its sleeve. Let's take a close look at some of the major features that I'm keeping an eye on that will impact what our ultimate precipitation is in southeastern Pennsylvania, northern Delaware, Lehigh Valley, and interior southern New Jersey. So I'm looking at the upper levels first. This is the 500 millibar map. This is a good 30,000 feet up in the air. But this is the steering currents. This will be where the precipitation, well, the direction that it'll head. And I'm looking at the steepness of the upper level flow. So I can show you the current run of this model compared to the most recent one. And just watch how the line or the flow gets a little flatter, relatively speaking. It's very subtle, but these subtle differences of 25, 50 miles will make a significant difference on what you see in your backyard, wherever you might be. Unless you're at the coast or close to the coast in New Jersey or Delaware, you're going to see all rain. But if you're in Philadelphia, and especially points north and west, these 25 to 50 mile per hour bumps will make a big difference. So you can see the previous run, so previous run, current run, previous run, current run. See how it's a little bit flatter, so the precipitation will come a little bit farther to the southeast. And the point of this is, with low dew points in place to start, I foresee the majority of southeastern PA, northern Delaware, southern New Jersey, right along the Delaware River, the majority of our snow will come from that initial batch of moisture that'll ride up and over that cold, dry pool of air. And as the dew points start lower in the 20s, and the temperatures might even be above freezing when the precipitation starts, it can still snow. There's an aspect called dynamic cooling or wet bulbing, where the temperature starts to decrease when the precipitation comes down, your dew point starts to rise, and they'll eventually meet at a point where it could still be cold enough to snow if the dew point's low enough, or there's a depression between where the dew point is and the temperature. So I see Philadelphia and points north and west getting a period of snow to start because of that. Another aspect is where this high pressure in southeastern Canada is going to set up. A challenge that we've been seeing, and the reason that you're seeing or you're hearing more of a chance for rain, or at least a changeover to rain in southeastern Pennsylvania, for example, is in part because this high pressure has slid farther to the east, which would induce an onshore flow from the relatively mild ocean. Ocean temperatures are in the mid to upper 40s, close to 50. And when you have a low pressure in the southeast and a high pressure rotating clockwise in southeastern Canada, low pressure rotates counterclockwise. It just brings the onshore flow. So ideally, you want this high pressure north of New York, so the flow comes down over land and does not go over the relatively mild ocean. It stays over the colder land. In this case, though, what you'll see is that high pressure, it's kind of tough to tell, but it's pretty far north or northeast of Maine, a little out of position. So the low pressure is in a pretty decent spot. We've had snowstorms in Philadelphia with low pressures taking this pass. High pressure too far east. So what we're seeing is an onshore flow, more so than we thought a day and a half, 2 days ago, that is bringing just enough mild air to change that initial snow pretty quickly over to rain, especially south and east of the city and the city itself. The question is, and what we need to track over the next day, day and a half, is does this high pressure continue moving farther east, or does it anchor a little farther to the west in the more ideal position? That will make all the difference when the precipitation comes in. As the precipitation starts to ride up the East Coast, I want to show you something pretty cool where, as I mentioned before, the concept of dynamic cooling or wet bulbing, when the temperature drops down and the dew points rise up until they meet to 100% humidity, is, and I'll show you first just the precipitation map. This is just one of the computer models that shows how it starts as snow even in areas south of Philadelphia. Now this could change, obviously, could go south, could go north, but I do believe that the majority of snow for in and around Philadelphia, if any, will be from this initial precipitation. This is called warm air advection, where warm moist air is overriding that dry, cool pool of air that was left there from a high pressure that slid off the coast. So I put this into motion, you can see the rain-snow line start to creep north and even change to heavy snow. So when the heaviest echoes come in, there's just enough cold air left in the atmosphere that, depending on the intensity of the precipitation, you could go between rain and the lighter precipitation to snow and the heavier precipitation. So it's not going to be an efficient snow accumulation as far as areas right on the edge, but when you're close, sometimes you need to smell the rain to get the heaviest snow. I know it's kind of cliche. In this case, it's true. Now it'll be a heavy wet snow for those areas that get it, so just northwest of the city. And it'll get a little bit drier as the atmosphere is farther below freezing as you get closer to Lehigh Valley into the Poconos. But let's take a look at temperatures and dew points, or the temperatures, and I want to show you what dynamic cooling looks like on the temperature map. As the precipitation comes in right now on this map, I know you can't see the radar or the projected radar, but it's over the DC. And as it comes up, just watch this. So Philadelphia 34 degrees, Lancaster 34 degrees. As the precipitation starts to fall, even though we're in the middle of the day on Saturday, you'll see the temperatures drop. So right about then is when precipitation's entering the area, and the temperature went from 34 down to 31. And even in Philadelphia, right on the edge, 33 degrees, about as close as you can get between rain and snow. But this is the dynamic cooling that will take place, especially inland from Philadelphia, when you get into a little bit of elevation, and most especially in central Pennsylvania, northern Lancaster County, Berks County, Lehigh Valley, and definitely the Poconos, northwest New Jersey. But this is the saving grace for snow lovers, I foresee, and this could be when the heaviest precipitation actually falls, too. So there could be a 2, 3, 4 hour window where you see moderate snowfall that could leave, coating to an inch in the city, could be upwards of 2 to 4 inches the farther north and west you go. And then when you get into the Lehigh Valley, where it'll be predominantly snow and Poconos, you'll be dealing with more than that. One of the wild cards that has popped up recently has been trailing energy. So what we see here is the initial batch of energy that's bringing us the warm air advection snow over the cold pool of air. Watch as I put this into motion as we go through Saturday night, into Sunday. You'll see this piece of vorticity or energy in the upper layers of the atmosphere that is quickly catching up to the initial shortwave energy from the lead system that we're going to experience. And as this does catch up and phase with this energy, the question is, how soon will it phase? The closer to the coast it phases, the more precipitation will be thrown back or enhanced. And this is especially going to benefit New York City, but in particular Southern New England, Central New England, as it stands now. But this is an example of a wild card for a boom scenario, focusing mainly to the northeast of our area. Just something pretty interesting to show. And as you see, as it phases with the lead energy and the trailing energy, it actually closes off in the upper levels. And when it does this is when it really does enhance the precipitation and more precipitation blossoms. So there's a chance that the Lehigh Valley, Poconos, and potentially the Philadelphia area gets clipped by a little bit of reforming or blossoming precipitation on Sunday. So this could linger some light snow or rain showers after the main batches come through, all the way through early part of Sunday, potentially Sunday at lunchtime. This is a big question mark, though. So that's just a general gist of the main things we're looking at, just to recap. So we have the angle of the upper level flow, which will dictate where that main initial precipitation batch will go. The high pressure over southeastern Canada. The farther east it goes out of position, the more of an onshore flow and warmer conditions we'll see, a quicker changeover from snow to rain. The farther west, it will help actually keep less of that onshore flow on. It could impact additional snowfall totals in especially southeastern PA. We'll be keeping an eye on the dew points and temperatures. The quicker that precipitation comes into the area, the better the odds for dynamic cooling to bring the temperature down cold enough for snow for a couple hours, including the city and even just south and east potentially. And then that wild card with that trailing energy, which will be for later Saturday night into Sunday. So as far as accumulation totals that I'm projecting, take a look at the first call snow map. We have different zones here showing the expected amount. Boom and bust means boom, higher end possible totals. Bust meaning worst case scenario. So 0 for most of southern New Jersey, coating to an inch around the city and the immediate suburbs, 1 to 3 inches in central parts of Chester, Montgomery, Bucks, 3 to 5 inches in the very far parts and then lower part of Lehigh Valley, Berks County, and then 5+ when you get up to the upper Lehigh Valley into the Poconos. Boom could be up to 9 inches in those areas. You can see this, and the low end here too. So first call snow map. We'll make updates as needed.